Hey guys, my name is Tom, and in this video I will show you with as much intuition and visual insight as possible how to solve a concentration exercise. In other words, a percent concentration exercise with two substances. We will take a highly graphical visual approach. We can answer these kinds of questions in simple cases with pictures. So this is what you do. Imagine you have a container. So I'm drawing a container here, okay? And say you have some substance in this container up to the top, and let each little box that you see represent 1 ounce. So this whole container here is 1, 2, 3, 4, 5, 6 ounces. If you have some substance, it doesn't matter. Now imagine that of this, 1 part is gold. So shade that in. Okay, that is your 1 gold part. Then imagine we will have another container that is only 3 ounces, like that. Okay? And now we will add them together, meaning we will form a new substance. Well, now this one is 3 ounces, so let's write that down below, okay? So we have that for reference. That is 3 ounces. And we don't know what the concentration is of gold in this one just yet. But take a look. This is so easy when you do it with pictures and simple cases. If you've got very, very big numbers, then it's not so easy. But in simple cases, when you're building your understanding, your intuition, you've got to take an approach similar to this. And then take a look. You will take your 6 and you'll add 3, which means now we have a new container that's 9. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw that container. And say somebody comes along and says, when I add these in the final container, 3 pieces are gold, like this. 3 of 9 are gold, which means if 1 comes from here, and you have 3 altogether, how many must come from here? 2. That's it. So the concentration of gold in this one is 2 out of 3. Okay, so we can write that down. The concentration of gold in this substance is 2 out of 3. Okay? It's the concentration of gold in the substance. You can also think, however, in terms of ounces themselves, right? Which means the following. If this whole thing is 6 ounces and one of those 6 pieces is gold, then that's like saying that 1 ounce is gold in the first one. And you know, it becomes silly after a while. Then 2 ounces have to be gold in the second one, so that when you add them, you get 3 ounces in the final mixture. Okay, do you see how intuitive mathematics can be? Okay. Now let's take a more traditional approach. But to make any sense of the traditional approach, you've got to build up your intuition with little pictures like this. Okay? So let's take a look at what we have. The traditional approach says this. You've got your 6 ounces, and then you're told 1/6 is gold. So you will write the following statement first. Of the 6 ounces, 1/6 is gold. So you're taking 1/6 of the 6 ounces, and then you're told the following. Of the second 3 ounces, some percent is gold. We don't know what it is, so you can introduce an X to represent that quantity. Okay? And then when you add these, the gold in here plus the gold in here, that's got to be equal to the concentration of gold, or the amount of gold in the final mixture. which, you know, somebody says is 3/9. Okay, so 3/9 is the concentration of gold in the final mixture. So that looks like this. Okay, 3/9 times the 9. And take a look. 1/6 of 6 ounces is 1 ounce. You keep this one here exactly as it is. So you write here 3x ounces. And then you write, cancel off the 9s, and you have 3 ounces again. See? So now let's drop the ounces because we don't need them. We've got 1 plus 3x equals 3. Subtract 1 from both sides. And you see that in this case, the equation-based approach is already probably wearing on your nerves just a little. Okay. So subtract 1 from both sides. You've got 3x equals 2, and then x equals 2 over 3. And this fraction tells us the following fact. Of the 3 pieces, of the 3 ounces here, 2 of them are gold. So it confirms what the picture found. Yes, this is one approach. And the other approach is this. Here the x was the concentration. It was the number of gold pieces out of all of the pieces in the second container. If you take, so notice in simple cases, a well-drawn picture will answer a question, and it's super fast and much more intuitive and powerful in terms of actually enabling you to understand, right? This equation business, that is already mystical and abstract and okay. But you've got to be able to do it this way too, because sometimes the numbers are big and this approach is difficult to reproduce. You can still do it though. It's with enough imagination, you can do virtually anything fairly well and quickly. So, but the imagination comes from drawing the pictures, not from working with symbols. It's you can also take an approach that looks like this. You can once again find, imagine you're told that 1/6, right, of this amount here is gold. So you will write that again. 1/6 of the 6 ounces, I'm not even using the ounces anymore, plus, and now you're told, for example, x over 3 times 3. The x that we find here will be different. It will be the number of ounces directly from the second container and not a fraction, meaning 2 out of 3. This will simply tell us how many and not out of how many. And this will be equal to, okay, this will be equal to the concentration once again, right? Which will be, we can tell here, 3/9 times the 9. So we cancel off. 1 plus, cancel off the 3's, x equals, cancel off the 9's, 3, which means x equals 2. So x equals 2, meaning there are 2 pieces that are gold, or 2 ounces of gold in the second container. So you've got the picture-based approach, you've got the equation-based approach, which is a little menacing when you first look at it, right? Because it does not seem very simple at all. And then you've got this approach here, and I think this equation approach is not so bad if you understand that instead of finding a concentration in terms of some number of pieces out of the total number of pieces, you are simply finding the number of gold pieces directly. Then this approach is not so bad because it gives you that too fairly quickly, more elegantly than this one here. So there you go. But I suggest to build any intuition, to make any sense of the equations, begin with a little picture. Thank you for watching.